Thank you very much. Welcome everyone again. My name is Sona Araste. I'm the communication officer at Max Weber Foundation for this lovely project, which is called the LUMEN project. We are here today to talk about the LUMEN Metrics Service. And without further ado, I will give the floor to my dear colleague, Licinia, who will say some introductory words.
Thank you, Sona. Let me just share my screen first. Can you see my presentation?
Yes, not in presentation mode yet, but yes.
Should be now. So thank you, Sona, and thank you to all the participants for being here. I hope this webinar will be useful and interesting to all of you. My name is Licinia. I am a researcher and a librarian at the University of Coimbra. I am part of the LUMEN project, and I will start this webinar with a short introduction. First of all, what do we refer to when we mention research metrics? This is about a complex list of indicators that regards different aspects of science, like impact, collaboration, societal impact, or open science. So we are not talking merely about statistics, although they can be present as a method for calculating research metrics. And when we refer to research metrics, we can see them in two main groups, the citation-based metrics and the altmetrics, the alternative metrics. And on the other hand, the research metrics, first of all, you probably will think about publications. It's the category that is most used when we talk about research metrics, but they can also be applied to other research outputs, and this is something that nowadays is increasing in importance and also in the concernings of the researchers to in a way to assess the research outputs that they produce beyond publications. We will address this topic in the webinar. They can be applied to authors, to institutions, or to journals. And maybe one of the most famous research metric, the impact factor, is applied to journals. But I've underlined here three entities: publications, research outputs, and authors, because they are what we are mainly addressing in the LUMEN project. So why this topic in LUMEN? The metrics service is one of the tasks of the project. We are now halfway through the project and the task itself, so the work is ongoing. But we have already identified some technical issues that arise when building a metric service. We have also been studying and taking a look of the initiatives on reforming research assessment, and one of the conclusions is that we need to address the need for transparent metrics in this service. So it is a broad topic. What we are going to present here is an approach that simplifies and helps better understanding research metrics, and we will also raise many questions, as you will see. Let me give you the context of the project and the task in the project in LUMEN. It is part of the work package 6, multi-platform innovative features, and the task metric service is intended to developing usage and citation metrics for the LUMEN platforms at the levels publication, research output, and author, in line with the principles of responsible research assessment. The partners of the task are the University of Coimbra, where Susanna and I come from, the University of Zadar, where Jadranka comes from. We have also the University of Bologna, which is responsible for an initiative called Open Citations. We have the IBL PAN, a Digital Humanities Center at the Academy of Sciences of Poland, and this institution is also in charge of coordinating the work package. And we also have OPRAS, the research infrastructure that has already a metric service in place, which is the background and the model that we are going to use in the LUMEN Metrics Service. In general, the goal of the LUMEN project is to enhance and produce discovery platforms to 4 scientific fields: Earth system, mathematics, molecular dynamics, and social sciences and humanities. In this last area, SSH, there is already a platform, Go Triple. It is a discovery platform where you can find millions of resources in the social sciences and humanities. And here you have an example of a board of metrics that you can find in one publication in Go Triple. This is provided by the OPRAS Metrics Service. And as you can see at the bottom, you can click on the definition for this metric, and you can see all the information about the way of collecting the data. And this is a good example of transparency in building a metrics service. So before we start diving into the metrics themselves, I would like to also give you some notes about the manifestos and initiatives on responsible research assessment and what they tell us about metrics and indicators. I'm referring to initiatives such as the San Francisco Declaration, the Leiden Manifesto, or the COARA initiative. And they all agree that research assessment should primarily be qualitative, centered on peer review, with the quantitative assessment complementing the first when relevant, and based on responsible use of quantitative indicators. Another conclusion that we can see in these initiatives is that they advocate for the access to scientific knowledge in different languages, which is something that we also address within this project. They also say that the differences in publication types and scientific fields should be considered when assessing research. And mostly what is more important here in the context of building a metrics service is that it is not the metrics and indicators themselves that are inappropriate, but rather certain uses that can be made of them to evaluate researchers or research entities. So when building a metric service, we are not dealing exactly with research assessment, but we have to take into account the principles of responsible research assessment in order to provide tools for that responsible research assessment to be possible. And one of the principles is to practice transparency by making available the data and methods used to calculate metrics. And now, before we hand over to Susanna to start learning more about the citation metrics, I would like to ask you to answer some questions on Mentimeter so that we can find out about your preferences and thoughts on metrics. And this can also be helpful for us in the context of building the task. So I will now stop sharing so that Sona can lead the Mentimeter session.
So I just shared the link you have to follow and the code that you need to access the Menti in the chat. It will also be displayed on the slides that you can see on my very screen right now. Okay, I will give you a second or two to get into the Mentimeter. So basically, this is a very, I would say, intuitive tool. As soon as you have entered the URL and the use code, which you can see here, you can easily join this slide, and I can see a lot of you have already joined. So I will slowly ease into the first question. So what you can do now is you can choose between the fields of research. Oh, I see. Most of you have already figured it out. So just that we have an impression of who is in this webinar and who is participating in these sessions. I can see a slight interesting. So there, oh, slight overweight of social science and humanities and other. We have so far no representatives of mathematics or molecular dynamics. Interesting. Okay. And I will go to the next question. So which research output metrics do you value most? I think this is something that probably will be picked up during the next presentations that we will hear, because it kind of touches upon the core of what we're discussing. And I will just give you a minute to think about that. So meanwhile, while we wait for people to decide, Lysenia, did you and your team actually expect people to choose number of citations the most?
Uh, in some way, yes, because it's the most common most common indicator that is and has is present almost in every database with metrics. So in some way, yes. But maybe social media, I would expect it to be more valued.
I'm sure we will talk more about that in the presentations to come. Okay, and last question for the introduction. So which author level metrics do you value the most? Yes, it just seems a bit more balanced. That's interesting. Okay, I think with this first impressions of what our participants value the most in metrics, we are ready to move on to the first presentation of today, which will be, I will just stop at this moment, which will be given by, sorry, by Susanna, and I will give her the floor ASAP.
Okay, I'm sharing my screen. Sorry. So today we will speak about citations. Citations are used mainly to track credit and to connect ideas. We know very well that there is nowadays there is a huge pressure to maximize citations and has also a huge negative side effects. Today we will not speak about these negative side effects, but we will speak about citation context, that it's extremely important. So, there are several bibliometric databases. The most known and the most used are Scopus, that has associated an analytical program and an analytical tool to calculate metrics that it's sizable. It's from Elsevier. We have also the Web of Science, and we have analytic program associated to this bibliometric database that it's insights from Clarivate, also dimensions from digital science, OpenAlex, from our research, Crossref with the analytical tool that it's Open Citations, and also Google Scholar that it gives some metrics, but it doesn't have any analytical tool associated and has some problems. So we know that these citation databases differ in many aspects, for example, in indexing methods, in coverage, in disciplines, and naturally it affects bibliometric measures that they produced. An important factor is the data accuracy of a database. And we know that a database is only as good as the data that it indexes. There are several problems associated with the data accuracy, and the errors in author names are very common, and are also very common some incorrections in affiliations, in institutional affiliations. To solve or to minimize these problems, it's very useful to use unique identifiers, persistent identifiers, and we have these identifiers to authors, for example, these ORCID, to the universities, to the institutions, R-award, and also to research outputs, the DOI. Databases are not comprehensive. We know that no single citation database covers all types of research outputs. And as a result, a citation analysis provides only a partial view of research performance. Another point that I would like also to mention is the changes in databases over time. That is other problem. We know that databases are continuous updated, not just with new, but also with older records. And many times when we see the growth in citations, it could be partially reflected in this expansion of this coverage of the database and not the increase of research impact. Thus, trend data should be recalculated, for example, annually to follow the trend. I mean, it's not a static value, it's a dynamic value. Let's see the other slide. Here we have an example of two quite known indicators and also useful in some research areas. They are CNCI, Category Normalized Citation Impact. It comes from Insights, from Clarivate, and the Field-Weighted Citation Impact. It comes from Seifel, from Elsevier. These two indicators are normalized both by field, I mean by research area. They are also normalized by year of publication and also document type. If it's an article, a review, a book chapter, and so on. So apparently they are very similar, but we will see that they are not equivalent indicators, and I mean they are not directly comparable. For example, if we look to the methodological differences between these two indicators, first of all, data source is different. One of them is calculated using the data from the Web of Science database, that is CNCI. However, the FWCI is calculated based in the data that comes from Scopus. And we know that these different sources has, for example, concerning, for example, coverage, different sets of journals. Another thing, for example, we know that the research areas, the schema for research areas is different between these two databases. So imagine that we have for these two indicators a value 1.5, 1.6, whatever. It does not represent the same citation performance. So here we see with an example that the context is essential. Now, speaking about the same thing, reproducibility changes, but in humanities, arts, and social science, that it's even difficult. First of all, the research outputs and also the impact are often difficult to measure in these areas because they include things like exhibitions, performances, digital media, sound and images, data sets, and so on. And we know that these type of research outputs are not well captured by bibliometric tools. So here we have a problem. It's not easy to apply some citation-based indicators to these areas, and sometimes it's not possible at all. So another thing is the citation practices. They differ from these areas to other disciplines, and normally these research areas, humanities, arts, and social sciences, they get much fewer citations. Another aspect is related with the authorship. It's very common to find research outputs such as articles, books, book reviews with a single authorship or with two co-authors, three co-authors. So, next slide, I would like also to speak about another aspects in the context of citations. The first aspect that we have here is related with the regional journals. We know that these, big databases that we see in the first slide of my presentation do not provide coverage or an adequate coverage of regional journals, and they have the same importance. They are comparable in quality with other journals that are not regional and that are very important. These regional journals in some disciplines, in some areas of knowledge. Also about the coverage of disciplines, that we can see variations in different research areas. We know that each citation database offers different coverage of disciplines that should be taken into account in a citation analysis. And another very, in my opinion, another very interesting question is, how can we use these databases to study the interdisciplinarity? Here we have a great challenge, and why? First, the interdisciplinarity can mean different things to different people, and also has different meanings in different situations. So it's really difficult to use these databases to inform, to assess the interdisciplinarity. Here we have a slide just to show what are the main research outputs for different research areas. And we can see that for natural and life science, we have essentially journal articles. For computer science and engineering, we have mainly outputs like conference proceedings, software, hardware. For social science and humanities, we have essential books, book chapters, policy papers, position papers that are also common. And in arts, we have outputs like creative works, exhibitions, performances. So as we can see, the research outputs vary across different disciplines. Indeed, the citation-based bibliometric indicators, they can work quite well in fields focused on journal articles, but they miss for sure key contributions in disciplines that use other types of outputs that cannot be evaluated using citations. So in the next slide, we have this schema that it's interesting, and we can see here the variation in frequency of publication, length of reference list, and also number of co-authors. That it's for art and humanities. These three factors are quite low. The frequency of publication is quite low. The length of reference list is quite short, and also the number of co-authors, as we seen before, is also small. But on the other side, we have life sciences and neurosciences that the behavior is the opposite. The frequency of publication is high. It's not comparable with arts and humanities. The length of reference list is quite big. We have an extensive list of references, and also the number of co-authors is also quite big. And we are not speaking here about the big science, but even in these disciplines, life science and neuroscience, we have a quite big number of co-authors per publications. And it has a consequence. If we have a high rate of publication, a big list of references, and also a quite big number of co-authors, the number of citations for these publications is also quite big. So we can see that the correlation between frequency of publication, length of reference list, and number of co-authors and number of citations, they have a positive and a strong correlation. In the next slide, I would like also to speak a little about the language representation. We know very well that the coverage of non-English publications remains a significant concern in the bibliographic databases. It's possible to publish in these databases in any language, but we know that the representation is not good. Also, we know that the non-English publications are more prevalent in some research areas, such as social science and humanities, than in other sciences, such as natural sciences and engineering. So here it's other problem to use these databases to calculate some metrics, and in this case that we are speaking in citations, it's extremely difficult, or I can say impossible, to use these databases to calculate indicators based in citations to these areas. They cannot be assessed by using these metrics. Another issue, and a very important indeed issue, is the attribution of authorship. We know that the citation analysis use different approaches to attribute this authorship in a multi-author publications. There are mainly two types of attribution. These databases can count it fully, equal credit to all co-authors, or fractional. They weight the credit among authors. But these databases and the methods used are blind. They are not supervised. So we know that there are differences in different disciplines related with authorship order. In some disciplines, we find the alphabetical order. In other disciplines, we see the contribution-based order, and they are not captured by citation databases. So the consequence could be a potentially biasing analysis. In the next slide, we have here not all of them, but a quite high set of citation-based indicators. These definitions are very simple definitions, okay? I'm not here presenting the exact calculation for all of these indicators, just to have an idea. So this slide, the goal of this slide is to show that the most part of indicators in the metrics in these citation-based databases are indeed focused in citations, and they are not applicable to all research areas. Behind this set of indicators that are citation-based, we have naturally the number of research outputs that measure the quantity, the size. We have also the types of collaborations that are not citation-based indicators. We have domestic, international collaborations with industry, and we have also indicators related with the type of access, open access, and the different types of open access. And to finalize my presentation, I would like just to say a few sentences. The first sentence here is citation tracking databases. We know that are widely used to measure research outputs through bibliometric indicators. They are really very useful, and introducing some, objectivity in some research areas. But it's not possible to apply the same methodology and the same set of indicators to all research areas. These databases, their underlying methods and limitations must be understood for correct interpretation of results. We are speaking again about context. The effective reporting should clearly state the data sources used, another very important thing. It should also acknowledge the limitations of those sources, and if any steps taken to mitigate these limitations should be explicitly described. And I'm finished my presentation. And thank you.
Okay, so now I will continue. Let me share my screen again. With the alternative metrics, we are still in the field of publication metrics. After this part, Jadranka will guide us to other research output metrics. So this term altmetrics or alternative metrics was introduced in 2010. There was a altmetrics manifesto at the time, and the idea was to overcome the criticisms on citations and to try to provide a broader picture of impact. And nowadays, it has become an umbrella term for metrics that are not citation-based. And in this case, we are talking about metrics that are dependent on digital platforms and data collection technologies. If you think of citations, you see that citations were used before we moved into the digital support for research. With paper publications, we still have citations. And now in this case of these metrics, they only have sense in a digital environment. And although they have been in place for all these years, they still have a limited use in research evaluation exercises. We see that research assessment activities still rely much on the citation-based metrics. And what is it that altmetric is measuring? Well, altmetrics at the beginning were said to measure impact of research, but we can add that it also it intends to measure dissemination, influence, popularity, attention, engagement, usage of research outputs. And here we are going to see some altmetrics in these three groups, focusing, as I said, in the publication level. And so for downloads, we can think about, for example, downloads of articles, of books or book chapters. The same thing for views, including here also the author profiles. If you think about the visualizations of an author profile as a measure of popularity, for example. And there's also the social web. Starting with the downloads, and here I'm referring to a well-known resource, the Metrics Toolkit. It is a web page where you can find different metrics and their definitions. It has not been quite updated lately, but it is still a valuable resource for those who want to know more about metrics. So we can say that the download is an event triggered by a user clicking on the download button in contrast to simply viewing a web page. So we see that we need to have the full text available in this case, and has usually as a PDF that we can click to download. And the metric would be the counting of downloads used during a period of time. But what can we say about the scope and limitations of this measure? Well, it can reflect the interest by a diverse audience, not only scholars, because if you think about citation, it is likely to come from the scientific community, but the ones who download a document or a publication can be part of the wide society, not only scholars. But on the other hand, downloading is not necessarily reading or using the publication. And if you think of, for those of you who still have paper books on your shelves at home, you buy the books, but you are not, most of them you are not reading, or some of them you are not reading. So it's the same about downloading. You can download PDF and keep it in your computer, but at the end you will not use it to your own research. And then there's also the risk of calculating downloads with no significance, in the meaning that there are tools that allow for automated crawling and downloading of content, and this may result in inaccurate counts. But just to give you a note that in this case, there is a tool, a code of practice by the organization Countermetrics that provides a standard for processing such data, including guidelines to avoid duplicate counting. And then you have to also see the context. Is it downloading from where? It is different if the downloading is from a publisher site or an institutional repository, for example, where the measures are likely to be more accurate, instead of other platforms that can be less reliable. But when building a metric service, you also have to decide and define where from are you going to count the downloads. It can be, is it in the platform itself when it is possible, or are you collecting data from other platforms? So this has to be decided, and the users must also have access to this information. And now about the views, we can give a parallel definition comparing with the downloads. A view is an event triggered by a user accessing a web page with the publication details. And the metrics would be the counting of views during a period of time. There are some variants in this case, because they can include the length of time viewed, for example, how much time the user spent on that page. And some tools also distinguish between an article's abstract views, full text views, or figure views, which is significant because we know that some platforms provide access to full text, not in a separate document or a PDF, but they can provide it in the website as an HTML, for example. And this would be important to understand these differences of viewing. But again, there is also the possibility of duplicate counting. For example, the same user visiting the page logged in and anonymously. And it has to be decided if multiple visits by the same IP address are counted as separate visits or not. So some challenges that are in place when counting views. And then the context or meaning of this metric is also important, because the significance of counting views may be higher in a discipline-specific platform where you know that visitors are likely to go there because they belong to that discipline. And so it is the meaning is different in this case. And again, the problem of tracking access by humans or by bots. But this is something that I will give more details at the end of the webinar. And about the social web, there is a diversity of indicators in this group of metrics. Generally, it intends to trace interactions with the publication on the social, having the publication in as a basis on the social web, like in scientific, in reference managers, for example, or in social media platforms such as Facebook or LinkedIn, online repositories, in blogs, academic platforms, news sites, and Wikipedia. So a lot of sources that can be considered to build these metrics. And they allow for a faster impact measurement, comparing with citations, for example. But there's also the problem, the susceptibility to manipulation. You can think that likes and shares can be artificially inflated, as a good example to understand this possibility. And there are also some technical constraints. They depend on the use of unique object identifiers like DOI, which means that when these identifiers are present in the conversation, they can be tracked, the publications can be tracked. But when they are not present, they will not be taken into account. Well, although some services use other strategies to identify the platforms, but they mainly rely on persistent identifiers. And there's also the problem of instability. When you think about citation, you understand that it will stay still or it will increase. But in the case of this measures, the score might drop. For example, an author can delete a mention, or data can turn into publicly accessible to private. So this is a feature, a characteristic of this type of indicators. And again, as the other ones, there is the dependence on digital presence of the references to the publications. So beyond the standard platforms for literature discovery, there is the need to the wider present on the digital world. And just to conclude this part of the Altmetrics, they are mostly provided by specialized services. Some of them are commercial, like Plumex, which is used by Elsevier, and others like Altmetric and Impact Story also provide Altmetrics. So now I'm going to hand over to Jadranka, who is going to talk about metrics beyond publications.
Thank you, Licinia. I hope you can see my slides.
Yes.
Yes, we can.
Yeah. Thank you. So we are all aware that current peer review and metrics are largely designed for articles or other types of textual reporting on research findings, like conference paper, book chapter, books, etc. And modern research increasingly produces outputs that matter just as much, like data sets, analysis software, computational notebooks, workflows, and code. And these rarely go through any formal review. And when they do, it's cursory. We realize that this creates a huge credibility gap. The data set, code, and software are really the most important things that make results replicable. And we all know how replicability is crucial in science. So speaking about different type of research output, you can see that we have many types of research output, more general in the left text box, and also it's worth to mention discipline-specific output. So, for example, in social sciences and humanities, we have annotated corpora, digital edition, data translation data set, etc., which is not present in some other disciplines. So because of the time limit in my talk, I will focus on data sets and code and research software. So, and maybe this is the good place because we are mixing code and software so much that maybe it's good to explain a little bit the difference. So code is, in the research context, it refers to scripts or program written to perform specific analytical task within the single study. And it could be data cleaning script, statistical analysis routine, a notebook that generates features or in particular paper. It is tightly coupled to the research it supports. and often not designed for use beyond that context, and frequently not structures for others to install and run independently. So code is answering the question, what computation did this study perform? On the other side, research software implies something more general and durable, a tool, library, or application that has been deliberately designed for use across multiple studies by researchers other than authors, potentially across disciplines. It has an architecture, versioning, documentation, user base, and expectation of maintenance over time. So research software is answering the question, what tool can researchers use to perform this class of computation? But before jumping to more quantitative metrics indicators relevant for data sets, software, and code, Licinia already mentioned the importance of peer review, and we are all aware how the reform of the research assessment system in Europe gained really popularity and support. And certainly in the future, more attention would be paid for peer review of not only traditional publications, but also research outputs like data sets and software and code. Sorry. When we are speaking about peer review, which I hope will become standard in the future, of data sets and code or software, here are some criteria which should keep in mind, and then it's about the most important there at the end, reproducibility and reusability. We are also often mixing these terms, but reproducibility, it's when someone tries to regenerate the results from the same data using the same methods. It's a kind of verification question, and the goal is to confirm that what was reported is correct. The data, code, and analytical environment are fixed. But when we are speaking about reusability, we can ask, can someone use this data for different purpose in different contexts to answer different questions? So it is utility question, and the goal is future value beyond original study. This requires not just the data be available, but that it's sufficiently well documented, structured, licensed, and the data researcher will, with entirely different aims or research questions in mind, can understand what the data represents, trust its provenance, and integrate it with other data sets. We can hope that in the future, peer review will really become more distributed and continuous, not only distributed to other types of research output, not only journal articles, but also not be such an article-centric model, which has 3 basic steps like submission, review, and publication. And maybe later we have some erratum, corrigendum, retraction. But when we are speaking about data sets, code, and software, these objects are living objects somehow, and they require more dynamic approach. So just it's not enough just to implement peer review on such kind of research output, but also to introduce something which will guarantee this continuous assessment, like post-publication review, version review, community review, etc. But what about more traditional metric indicators, which can be applied to data sets and code and software? Here we propose 6 categories, some classes, a kind of classes of metrics. And even yesterday I had only four categories, but what is important to have in mind that these categories are not unique in their meaning. They are not containing unique indicators. Often they are overlapping, and some of them can be used interchangeably, reflecting, for example, usage and engagement at the same time. So I will shortly explain each of these categories, and you have some other categorization in mind, which is better than this one I'm presenting. Please let us know. So it's quite simple when we are speaking about usage metrics. It's focus on downloads, views, visits, counts, standardized via counter, which Licinia explains perfectly. And this is for research data, most operational metrics on the usage. It's really mature. But a better understanding of how to measure data impact is critical if we are to reward data creators or incentivize data publication. Researchers found citation and download counts much more useful than, for example, search rank for that purpose. So we are using quite similar indicators for datasets and code and software. But the situation is quite different when we are comparing metric indicators for citation and reuse metrics, where we added subcategories, for example, for datasets, reuse, fair quality, and trust indicators, which are really important for such kind of research output. And for code and software, there are also 3 subcategories, like adoption, reflecting through installation, package downloads, dependency networks, which are showing how this code or software is used, and statistics offered by GitHub. Community engagement, it's reflected through the number of contributors, issue resolution rates, and maintenance activity. And for quality, we can run test coverage, see how often are new versions of the software released. We can look at the documentation quality, etc. For quality metrics, maybe this is the most complex kind of metrics for non-traditional research output, and we are really happy that there are two frameworks which are existing for quality metrics for datasets on other side and software on another. So for datasets, we have the more structured attempt to define quality dimensions. For research data publication is a POCME framework developed by the Helmholtz Association Task Group on Quality Indicators for Data and Software Publication. And we are looking in that direction. We should really follow what this group is working on. They are really offering a good framework for metric indicators for data sets assessing its quality. So they're proposing a modified version of FAIR principles called POCME, as I mentioned, consisting of 5 dimensions: publishing, openness, curation, metadata, and external view. Where publishing emphasized discoverability and accessibility through identifiers and repository indexing. Openness goes beyond mere publishing to consider licensing and ease of access. Curation focus on data cleaning, documentation, and enhancement of reusability. And metadata considers both formal metadata and content-related metadata for understanding the data. And they quantified each dimension using a scale from 0 to 5. So it's not a simple number reflecting the quality. But what is new, they added this 5th dimension in framework, which is external view. And external view, it's somehow the purpose of this indicator is to compensate inadequacies between different scientific disciplines when applying in such a general framework. So then we can consider the other 4 dimensions quite as universal standard. External view is something different, and it covers signals such as citation and reuse evidence, community recognition, peer review record, or disciplinary fit. So for code and software, we have a FAIR ST framework developed, also developed by the Helmholtz group, and they are actually offering 6 dimensions of such a framework, and you can see that first 4 are actually replicating familiar FAIR criteria, but they added 2 important dimensions. First, scientific basis, which reflects, does the software correctly implement its described methods? And it is validated. Is it validated against known results? And technical basis, does it have a test suite, continuous integration, pipeline, version control, and such kind of things. Compliance metric measure adherence.
I'm sorry.
Yes.
Could we slowly come to an end of this presentation?
Yeah.
Thank you.
Compliance metrics measure adherence to external requirements, funders, mandates, publisher policies, institutional policies, rather than intrinsic properties of the research output. And you can see how we can, for data sets, we have already develop indicators for compliance metrics. It's much more complex for code or software because object is harder to define, different version, licensing is more complex, and there are really not established standards for such kind of compliance. So we have some initiatives trying to solve this issue, but not widely adopted. And related to community engagement metrics, we can also look at several aspects: attention, adoption, infrastructure embedding, community health, which is really nice indicator, actually reflecting characteristic of the community developing code or software, teaching, training and teaching adoption, policy reach, etc. For the it's obviously it is missing. We are all aware that peer reviewers are overwhelmed with their task reviewing different journal articles or other traditional publications. So when there is a lack of validation or career incentives, it's really difficult to expect that peer review of non-traditional research output will become a kind of standard. So it's also a problem with the reviewer expertise. So it's this type of reviewing require completely different skills, which most of the researchers don't have. There is also standardization needed, and having in mind specific characteristic of data sets and software, these metrics related to longevity needs to capture not just initial quality, but long-term maintainability and accessibility. And we don't have a lot of gaming in the area of metrics for non-traditional research output, and there is a simple reason for it. They are not widely used and implemented at the moment when they will be more represented, then the gaming will be, of course, a part of it, like when we are speaking about traditional. My last slide is related to some important messages. So the metric ecosystem for non-traditional output is really immature, but it's actively developing. Quality, impact, and compliance are distinct dimensions and require distinct metrics. Peer review of data and software, it's not single practice, but represents more a kind of spectrum. And we already have some examples of reviewing such kind of research output. Statistical editing is currently practice, which is currently in practice. It's largely decoupled from the data. And it's pity that even we have statistical reviewers as a part of editorial board in many journals and many publishers. They do not have data on disposal. They are just checking tables and a graphical presentation for kind of consistency, but actually they are not able to repeat statistics and confirm and validate this analysis. Reproducibility and reusability require different interventions. So reproducibility is about validating the past, confirming that results are correct. Reusability, it's about enabling the future, ensuring the data and software are well-documented structure and that will be used in the future. Distinction between coded software matters and community engagement metrics need to go beyond alt metrics and GitHub statistics. Attention metrics capture whether an output was noticed. They do not capture whether it was trust built upon or embedded in the community praxis. And I will finish here. Thank you.
Thank you very much, Ranka, and I will give the floor to Lisinia right away.
Lisinia, you are muted.
Sorry, thank you, Leah. So I will conclude with the 2 slides about the technical issues that can be invisible for many people, but decisive when it comes to the production of metrics. Talking about citations, of course, to produce these metrics, they have to have access to bibliographic references. So there is the question on the openness on metadata that this issue raises. And that's why initiatives as the Open Citations that advocate the openness of data, of citation data publications are crucial. And on the other hand, most metrics providers depend on DOI existence to identify citations. And in this case, they usually and mostly rely on Crossref as a key source, but we must be aware that there are also other DOI registration agencies. And not only for citations, as we have seen, but also to calculate altmetrics, there's also a high dependence on DOI. Another point about the arts and humanities specificity. In this case, the citation is critical due to the longevity of publications. Susanna has already mentioned some questions about calculating citations for arts and humanities. But I would also mention that, in addition, that in some cases, researchers in arts and humanities still use publications in paper that may not have an online presence, and then they will not be taken into account to the calculation of metrics. So there is the need of access to sources for counting indicators, and some of them more complex. If we think about the recent initiatives to categorize citations based on the context of the index citation, thinking if we are in the field of a citation that is positive or a citation that contrasts, or based on the part of the article where the citation is made. So some tools attempt to provide metrics on this specificities, but it means that it requires the access to full text for data mining, which is of course limited. There's a lot of research outputs and publications that are still closed. And then there is also the question of the sustainability of open infrastructures. Are investments sufficient to provide the sustainable infrastructure in the long term? And then the question of that the technical requirements and the capacity may not be able to provide complex indicators. For example, the citation indicators that Susanna showed us before are mostly dependent on commercial providers. And finally, I would like to present this last slide regarding a pressing issue, the problem of bot access and how to distinguish it from human access and how to quantify the value of this impact. So we can say on the one hand that systems must be able to distinguish between human and machine use of publications. Actually, this is a problem it is nowadays, it is a hot topic, but it is a problem that was identified decades ago. Some studies on this topic have been around for several years, and you can find some of them in the bibliographic references of the presentation. But if you see, for example, this article published in Nature in May, that concludes that research papers are increasingly being written by artificial intelligence, then we can ask, what is the meaning of tracking non-human metrics when scientific writing itself is becoming less and less human? Or in other words, if papers are written in AI, by AI, should we exclude their usage by AI? So where are we heading in this context? So these are the references that you can consult lately. We will share the slides. And two last questions with the Mentimeter. Sona, please.
1 second, I will share my screen again, and I will also... no. I will also share the link to the Mentimeter, which should make it easier for you to join directly. So, okay, you should now all be able to see my screen again. And you have the link to the Mentimeter in the chat. The code is displayed at the top. So, I don't know, Lucia and the team, do you have any expectation for how this should be answered by participants? So is there anything you would like to see in this answer? More of a yes or a no question?
Well, we were trying to here in the webinar to raise the question of the importance of researchers and everyone that use metrics to be aware of the way they are calculated. But so we wanted to understand if this is a concern that people have in mind when using metrics.
I mean, the good news is obviously no one has chosen no so far. So I think we can count it as partly a success. If I look at the clock, I will slowly go to the next question, so we can maybe have a closer look at the last question. So, I mean, obviously, I think all of you three want people to answer kind of yes, probably. But I mean, what is interesting and what maybe we can spend a few minutes to discuss is, if your answer is yes to this question, how so and why? Because I think these are the bit of gold nuggets in terms of discussion making that can actually help our team develop the metric service further. Okay, so I will leave the Mentimeter open for that, but we can also start a discussion. So if you have any questions, we are happy to take them. Okay, so I see one comment. I don't know. I think we aren't that many people anymore. So if anyone wants to raise their hand and actually speak, I think that's also completely fine. So the answer of one of our participants is I respond no, because in the first question I said none of them are more valuable, which I think is a decent stand. I don't know if you want to elaborate on that maybe. No, no worries. Actually, you know what would be interesting if we maybe mirror that kind of question back to our speakers. So why would you think such a stance is valid? So what does this say to you about the value of research metrics? Which ones do you value most and why?
Well, my answer is similar to the one by our participant. It's our job. I think Susanna will agree with me. We are bibliometricians, so we don't have to value them. We are neutral in this case. I don't know, Susanna, what do you think?
Yes, I agree, but for me it depends on the research area, you know. Bibliometrics it is very useful in research areas where publications, I mean, classic publications, articles and reviews and the proceeding papers are the main research output. And with the bibliometrics, we can say, I mean, in these areas, okay, we can say quite easily if we are working with high impact publications, and we know that the impact in these research areas has a positive correlation with quality. We can correlate the impact with quality. I know that it's for sure there are a lot of people that they don't agree. But my background is, for example, is from chemistry, and sometimes bibliometrics is enough, and we don't need, supervised a human evaluation. But just in some cases, okay. But I understand that in some research areas it's very complicated, or almost it's impossible to use these indicators.
Thank you. Okay, so I think this is a comment by the same participant, which I will just read out so everyone can participate in that. So with all the manifests that we have signed, we need to use them, but criticize them. We signed also the more than our rank. So yes, for me, all of them are the same, especially when people try to use them to just do a better score with a publication and not to improve the research. And I actually think that's kind of a nice wrap up, unless, of course, anyone has more questions. Because this basically points at the very core of the problem. Research metrics should be about improving research and not about improving reputation. And if you want to keep in touch with us, you are more than welcome to follow the Lumen newsletter. You are more than welcome to follow us on social media. You are more than welcome to send any of us an email if any questions concerning this webinar arise later on, or any questions concerning the Lumen Metrics Service or any other Lumen output. So we would love for you to stay in touch. And if there are no more questions, at least I don't see any, then I would thank all of you for being here today. Thank you. I hope you all have a lovely day and see you soon. Bye.
Thank you very much.
And a special thanks to our speakers, of course.
Thank you.
Thanks.
Very
Bye.
much.
Thank
Bye.
you. Bye.
Bye.
Thank you.